Hello everyone. Today we're going to do a lecture on dental waxes. This lecture is to be used in accord with the outline in your module, so make sure you take a look at that and become familiar with the content in there as well, because all of the material is going to be potentially test worthy, so keep that in mind. The objectives are listed here. You can stop the recording to look those over. So here is a page of objectives, as well as this page. The introduction to waxes is to know that there are many different waxes that are used today still in dentistry. The composition, form, and color of each wax are designed to facilitate its use and to produce the very best possible results. There are different components that are added to attain the physical properties desirable for the specific application for which the wax will be used in your procedure. Dental waxes are composed of a mixture of components from both natural and synthetic sources, so natural found in nature and synthetic that are man-made. Natural waxes are produced from plants. They are used in carnauba wax. They can be from insects, which are used in beeswax, and minerals, which are found in paraffin wax. These natural waxes contribute properties to the wax, but are rarely used in their pure form. Synthetic waxes contain gums, fats, oils, resins, and coloring agents. When we talk about melting, we have to remember that dental waxes have a melting range. That is a range of temperatures at which each component of the wax will start to soften and then begin to flow. So that softening happens first, and then the flow happens second. Components with lower melting points will soften first, and then as the temperature is increased, more components will soften and the wax begins to flow. The flow is the movement of wax as its molecules slip over one another. As the temperature of the wax increases, the viscosity of the wax decreases until the wax becomes a liquid. Because wax is unstable, the operator, that's you, must use care not to cause distortion of whatever wax you are using and trying to record information with. So controlling the temperature of the wax will allow the operator control of the viscosity and then also the flow of the wax. To prevent distortion, the melting range must be higher than the temperature of the environment for which you're working. So the definition of flow is the movement of the wax as it approaches a melting range. Controlling the flow and the melting range is an important factor in manipulating wax. It is important that the dental wax chosen in the procedure is placed in a patient's mouth does not require temperatures to be much greater than the mouth temperatures to soften, or it would be too hot or uncomfortable to the patient when it's placed intraorally. Lab waxes can have a higher melting point, as they typically do. They do not get placed in the patient's mouth because they are going to be used in a lab, not in a dental office. All waxes must be removed from the object onto which it is melted. So this is called the excess residue. All of that residue has to be able to be removed. If a residue remains, this may result in inaccuracies in the object being produced. It's especially important to make sure that the excess residue is removed in the lost wax technique, which we'll talk about at the end of this presentation, and you will view 2 videos about that technique. As far as thermal expansion, we know that waxes expand when heated and contract when cooled. The thermal expansion and then contraction of waxes is greater than that of any other dental material. Please notice that that is bolded for you to remember. Manufacturers provide temperatures and handling guidelines for pattern waxes to prevent inaccuracies in the final casting that is created. If waxes are allowed to stand, dimensional changes occur from the release of residual stress. Wax patterns should be invested within just a few minutes of carving so that they do not distort. Again, waxes expand when heated and contract when cooled. The thermal expansion and contraction of waxes, again, are greater than that of any other dental material. So that is pretty important that it was bolded and in this presentation a second time. This property is especially important for pattern waxes. If a wax is heated too far above the melting range or is heated unevenly, expansion above acceptable standards will result. There are 3 classifications of waxes. We have pattern waxes, processing waxes, and impression waxes. Pattern waxes are also known as inlay, casting, and base plate wax. Processing waxes are known as boxing, utility, and sticky wax. And impression waxes are known as corrective and bite registration wax. Manufacturers produce these waxes in several forms. They can be provided in sticks, in sheets, in blocks, and also in a tin. Waxes have unique coloring to distinguish them in use, and as we get through this presentation, you will see some different colors that are pretty common for the different types of waxes. Pattern waxes are used for constructing metal castings and bases for dentures. A pattern wax is sometimes called an inlay wax, which, of course, by its name is used to prepare a pattern. These patterns are reproduced in gold or other material in the fabrication of inlays, crowns, and fixed or movable partial dentures. Inlay wax is sometimes called casting wax, and this wax is supplied in sticks, pellets, in tins, and it's generally in dark colors of red, blue, or green. It can be labeled as hard, medium, or soft, which is referring to its melting range. The properties of inlay wax states that for success in these procedures, the wax must have properties that will enable very close adaptation to prepared proportions of the tooth to be restored and must provide freedom from distortion. It must permit detailed carving without flaking or chipping, and it must not leave excess residue when it's removed from a mold by burning when we do the burnout process from the lost wax technique. Inlay wax should harden at body temperatures but soften at a temperature low enough to permit it to be manipulated in a plastic state in the mouth without injury to the pulp or oral tissues. Its colors should contrast with the colors of the teeth and oral tissues to facilitate its carving in the mouth if that's where it's going to be worked. So here are a couple pictures of pattern or inlay wax. Here we have some blocks that would be easy to kind of chip one another away. Here are just some solid blocks. Here is a tin full of the wax, and here are the sticks. This is a die with an inlay that is being created and fabricated in this tooth model, and here is a full crown that has been waxed up. It's the wax pattern, and we have this casting rod or sprue that is here to push the metal into the burnout when this wax is lost, and we'll look at that in a little while. A casting wax is used to construct the metal framework of partials and complete dentures. This type of wax is supplied in sheets and in preformed shapes. The physical properties of this wax are similar to inlay waxes, except for the melting range. This type of wax is not softened in the mouth, so the melting range is much higher, and it's important in this aspect for the laboratory procedures to have a higher melting range. Here are a couple of pictures, and these casts have the wax built to design partials for the maxillary and the mandibular arches. Here is a picture of how it's supplied in these sheets, and then these other types of designs. And in this picture, this is actually not wax. This is something I think that's going to be kind of the wave of the future, is a 3D print of the cast and then a 3D printed model of the framework for this partial. So this is a tried and true method to make a partial. I think this is going to be the wave of the future to fabricate partials going forward. Base plate wax, the general purpose behind this wax is that it's mainly used to create occlusal rims. and to also hold artificial teeth to the base plates during the fabrication of dentures. So we have the base of a denture, so this is the plate portion of the denture, so you kind of get its name and its function all together. So the properties of this wax is that it's composed mainly of beeswax, paraffin, and a coloring component, which are all mixed together, cast into blocks, and then rolled into sheets. So base plate wax is almost always going to be in a pink sheet. These are supplied in sheets and are typically pink in color. The sheets are layered on top of one another to produce the contours of the denture and to hold the position onto which the denture teeth are then set. The wax must not distort at mouth temperatures so that the wax doesn't move and shift when it's being tried into the patient's mouth. So here we have the base plate wax in its sheets. Here we have it kind of melted and softened and adapted to the edentulous cast. And you can see this pink wax that's been built up and is now holding the teeth and the pattern for this new denture that's being constructed. Processing waxes are used primarily to aid in dental procedures, both clinically and in the lab. The first one is boxing wax. Boxing wax is used to form a box around impressions of the mouth when a cast is made. This boxing of the impression limits the flow of gypsum or stone material from around the impression. The boxing wax usually is issued in red strips that measure 1.5 inches wide and about a foot long, and it's about 1/8 of an inch thick. Boxing wax is very soft and very pliable, even at room temperature. This allows it to be formed into a desirable shape without heating it. So here's a look at boxing wax in its forms just coming out of the box. And here's the impression, and we wrap those strips of wax around the impression to keep the gypsum or the stone, the plaster from moving and traveling all over. So then once the plaster, the gypsum is set, we remove the wax, we remove the impression tray, and then we have our good cast. Utility wax is used to provide rim locks and is otherwise used to adapt impression trays for individual impressions. It's used to build up post-dam areas on impressions and also form a bead or border on preliminary and final impressions. You used utility wax when you were adapting it to the impression trays when you took impressions on the mannequin and on your friends in materials lab. Utility wax is also pliable at room temperature, and you can use this without heating it as well. Utility wax normally is issued in stick form and is usually white or red. This wax can also be used for ortho to protect the soft tissue when a bracket or an arch wire is poking. Here's what utility wax looks like. It comes in those little strips. Remember how you peeled it from each other in the box and then adapted it to the impression trays. So that is utility wax. Sticky wax becomes sticky when melted, otherwise it is not sticky at all, and has the property of adhering to surfaces of various materials. Sticky wax is composed of beeswax, paraffin, and other resins. Sticky wax usually is supplied as hexagonal sticks of various colors, often orange or purple. Sticky wax is brittle at room temperature and assumes a thick liquid consistency when it's heated. Because of its brittle nature at room temperature, even the slightest torque on the material will fracture it. This is an important characteristic because it alerts the operator that distortion has occurred during its manipulation. So here's a couple of photos of sticky wax. Here's how it looks coming out of the box. It's that orangish color, and this person has a broken denture. So the sticky wax was melted over the fracture, and the dentist used some very long lab burrs to stick the burrs together to allow the wax to heat and then allow them to make the repair to the denture. So the sticky wax allows materials to stick together. It is not sticky at all in this form.